So for length here, we have to use the meter. In a few minutes, we're going to give you some problems and ask you to convert them from, let's say, feet to meters, yards to meters, inches to meters, but the distance you always want it to be in, or the length you want it to be in meters. The mass, it has to be in kilogram. You know a kilo is 1,000, a kilogram is 1,000 gram. A kilogram is roughly 2.2 pounds. The time has to be in seconds. We don't care if it took 2 hours and 38 minutes to get from here to New York. I need the time in seconds. The speed. The unit has to be meter per second. So we use for that m/s, meters per second. For time, we use s for seconds. For mass, we use kilogram, kg. And for distance, the symbol is meters m. Now, how do we convert from one to another, from one unit to another one? Let's see if I have the chart here. I'll switch to my screen here quickly on my machine. And I got that table here ready. Okay. 10,000 things open here. Let's say I came to you and I said, you know what, can you tell me what my mass is? I got on the scale this morning and it says I weigh 204 pounds. What is my mass in kilogram? Now, if I look at the chart here, let me just make it bigger so I get to see it. Time, length, mass, where is it? One kilogram. Let's see. 1 pound, the conversion here, or 1 kilogram equals 2.2 pounds. So how would I convert the 204 pounds to kilograms? The method I'm going to show you actually will work for any conversion. If I make it a fraction, 204 pounds over 1. I'm going from pounds to kilogram. I'm always going to multiply, not divide. Always the multiplications. Since pounds on the top, you want pounds on the bottom, kilograms on the top. I want pounds on the bottom, kilograms on the top. And now look at the conversion factor. That's this one. What's the number in front of kilogram? 1. What's the number in front of pounds? 2.2. Now the question you probably have, why do you want to have pounds on the bottom? I said, I want pounds to be on the bottom. Why on the bottom?
So they cancel each other.
Exactly. They can cancel each other out. Now you're multiplying fractions. If you remember from algebra, when you multiply, it's the top times the top. That's 204 over 2.2. And I forgot to bring a calculator with me. Anyone has one?
92.73.
92.73?
Yeah.
Now, what the book is going to do a few minutes, especially with the software, they're going to ask you to use significant digits. Or when you look at this, the 2.2 has how many significant digits? 2. This one has what? 3. They're going to say write the answer using, for example, 2 significant digits. Write the answer using 3 significant digits. Or if they decided not to do that, they'll give you this number as 2.20. You said, why they made that 2.20? By putting the 0 there, you just made that what? 3 significant digits. And that's 3 significant digits. Your answer should be what? 3 significant digits. So if you took chemistry, you probably know about significant digit. That was a big issue there. So you got to make sure that number is 92.7 because you want to make sure that's 3 significant digits. The good news, if you're actually off by 1 digit, like significant digit, they'll tell you. We'll give you the points for it, but they'll give you an explanation. You have the wrong significant digit. It should be 92.7, 3 significant digits. They try to give you a little tip. They won't mark it wrong, but they'll tell you that should have been 92.7. If you're at 92.73, they'll go correct, but they'll give you an explanation. Should be 92.7 because you have 3 significant digits and 3 significant digits. Your answer should be 3. So after about a class or 2 or a homework or 2, you become good at converting from one unit to another. Another example, they might say, I don't know, Jack ran a track here. Let's see. Decided to go this morning for a workout, and he went around the track here. The track looks like, shaped like this. It's actually a football field with a distance of 100 yards. Anyone knows the dimension of football field, the width of it? Is it 80? I think it might be 80 yards. I can't remember. And you have semi-circle on this end, half a circle, and half a circle on that end. If Jack decided to run around the track, and Jack did, I don't know who Jack is, but we'll use Jack. Jack did what? 10 turns or 10 laps around this. How far did Jack walk? And I want that distance now converted to meters. Well, let's look at one lap. Now remember, Jack is going to walk on the outside of the track. He's going to get on this end, start from here, and he's going to walk this way. That's where he's going to walk. So you know, if you look at one lap here, what is that equal to? That's the 100 yard here, plus the 100 yard here, plus half a circle here, half a circle there. Well, what is half the circle on the outside, half a circle on the other end? When you put them together, what do you have? Don't you have a full circle? I need to know the circumference of that circle.
85.
Correct. The circumference of a circle, it's diameter times pi, or 2r times pi. Diameter is twice r. So the circumference to go around a circle, it's actually d diameter from end to end times pi. So in this case, that will be 100 plus 100 plus d, which is 80, times pi, which is 3.14. And what do we have for a number there? I have a calculator on my phone here. 80 times 3.14 plus the 200. So it's actually 451.2 yards each lap. So if he does 10 of them, It's going to be 10 times 451.2, which is 4512 yards. Well, this is all good. Perfect. Except I'm not asking for the distance in yards. I want it in meters. How would I convert meter? I look at the conversion factor here on that sheet there. And it says, where is it? Let me see. I have a meter equals 3.281 feet, or 39.4 inches. I don't see meters to yards in one line here. Let me just keep looking. Maybe I'm blind. Do I have meters to? No, I see 1 meter equals, this is what I see. 1 meter equals 3.281 feet, which is also equal to 39.4 inches. So I have a choice there. I can change my distance from yard to feet, then from feet to meters. Because I don't have a way to go from meters to yards in one step. That's not an option for me. So I can go, let's take that distance, 4512 yards, that's over 1. Let me convert that to, it's always a multiplication, to feet, from yard to feet. Since yard on the top, you want yard on the bottom, feet on the top. 1 yard has how many feet? Is that 3 feet? Notice the yards are gone. Now if I just multiply that out, I'm in feet. Well, I need to convert that from feet to meters. Notice feet on the top, you want feet on the bottom, meters on the top. 1 meter is what? 3.281 feet. You multiply the two top numbers, you get one number, divided by 3.281. So let's see, what is 4152 times, that's 13,536 divided by 3.281. The distance is 4,125.57 meters. Again, if you want to use significant digits, you go, well, let's see. I had 2 significant digits, 2 significant digits. If I want to carry that to 2 significant digits, what is that number? 4,100 meters. So to 2 significant digits, that number becomes 4,100. Remember, 5 or more, we add 1. Why 2 significant digits? Because this was a 2 significant digit. That's a 2 significant. That's a 2 significant. They probably want the answer is 2 significant digits. That's how we convert the distance from feet and yard to meters. Yes?
I'm just trying to get how you got 4,100 instead of, why not 4,126?
Because you want to round it to 2 significant digits. These are not significant digits. So 2 that means that's your significant digit, a 1. So now either going to make that a 2 or a 1. You look at that number, 5 or more. Yeah. Now if you carry 4 significant digits, you're right, that'll be 4, 1, 2, 6. But you'll have 4 significant digits. These are not significant digits. You know, that's really the way I wrote that. The 100 is not a significant digit unless I write that. If I wrote this like this, point, that's 3 significant digits. 3, 3, and this is 2. If I made that, that's 3 significant digits. If I decide to go with 3 significant digits, my answer becomes what? Now, 4130. Because that's 3 significant digits. So if they want that to be, if you want to count, if there's no dot, you only have 1 significant digit. So if I don't put the dot, really my answer should be 4,000. Because that's 1 significant digit. So if there is no dot here, point, and point, you only have 1 significant digit, because the trailing zeros don't count as significant digit unless you put a decimal point or you put a bar over them. Yeah, I can eliminate that decimal point here out of this and put a bar over this 0, and that 0. The bar means that's the number of significant digits. I get 2 of them now. That'll be 2 significant digits. So if I do 2 significant digits, that's this number. If I take that bar out, and I put a decimal point here, I'm making each number 3 significant digits. That'll be my answer right here. And by the way, our software is kind of funny. In some examples, they do use significant digits, and others they don't use them, and they don't tell you when to use it, when not to use it. So sometimes like a guessing game. I was watching Discovery Channel a couple of days ago, and they were showing actually a lion attacking a baby gazelle there, and you feel bad for that. But they said the lion can actually explode, or the cheetah can go hit top speed of 60 miles per hour. 60 miles per hour, that's the top speed. You know, when it attacks there. For a short time, you know, a few seconds, and it gets tired. If it doesn't catch its prey for a while, it has to sit and rest for a while. Now you're wondering, like 60 miles per hour, just like if you watch downhill skiing and you go, oh, poor Johnny, you lost by 1 second. Well, if you're going 60, when you're going downhill skiing and you're going 60 miles per hour, 70 miles per hour, 1 second could mean the length of a football field. It just doesn't seem like a lot. But when you convert that to how many meters per second, you will see that if you lost by 0.1 of a second, you lost by a good distance. It wasn't even close. So let's convert that 70 miles per hour. What is that to meters per second? And we do have one that will take us directly from miles per hour to meters per second under speed. Where is that? Pressure, energy, power. This is what I see in the note there. 1 meter per second is equivalent to, I'll put them on the board here for you. Where is it? 3.60 kilometers per hour. Which is also equal to 2.24 miles per hour. So I want to convert 60 miles per hour to meters per second. That's 60 again, miles per hour over 1, multiplications. I want miles per hour on the bottom, and I want meters per second on the top. One meter per second is equivalent to what? How many miles per hour here? 2.24. So 60 divided by 2.24, 26.78 meters per second. So if you come a second behind somebody, If you are 1 second behind somebody in a race, you lost by almost 26 meters. That's almost 30 yards. That's a 1 second. If you come 2 or 3 seconds behind, you lost by a football field. So it seems like a close race. Oh, by second, 1 second, 2 seconds. When you lose by a tenth of a second, you lost by 3 meters. 3 meters probably from the wall to here. That's 1/10 of a second. Yeah. So when you watch these animals attack and people say, why don't you just jump out of the way? Yeah, good luck. Coming at you at 30 meters per second. Yeah. One Mississippi, they just traveled twice the length of this room. You dodge out of that. A bullet now goes about 700 miles per hour. You do the conversion there. You watch on TV in Hollywood, someone fires a bullet at them, you see the person diving, the bullet misses them. Yeah, good luck. See the speed of that. Now that's Hollywood there. The mass has to be in kilogram. The speed has to be in meters per second. Sometimes when the numbers are really big, we use other units. We call them kilograms, kilo. Or sometimes we use mega, million. So let's talk about these units. When you're weighing a car, you're not going to say, well, the car weighs this many. You might say tons too. And by the way, 1 ton here, where is it? I saw that early for mass. They might use tons there. 1 metric ton is 1,000 kilogram, 2,200 pounds. So when they say the car weighs 2 tons, 1 ton is 1,000 kilogram, or 2,200 pounds. I was watching RVs yesterday, extreme RVs. And NASA has an RV they're building, recreation vehicle. It's not that big. It's bigger than a bus. A little bit bigger. Actually, it's 16 feet long, but I think 9 feet wide, and like 8 feet high, 10 feet high. And maximum weight on that 80 tons, the maximum weight on it. That's an RV. Yeah. It costs $100 million to build. It's phenomenal if you've seen that thing. But then they were building the other ones that the average person uses here. But those RV are designed to go scoop things from the ground. The astronaut will be inside them on the moon, on a different planet. That's what the planet is, on a different planet with some astronauts, and scoop some dirt and come back, analyze it. So the suit built in, you just step in the suit, zipped itself, you go outside, you get the stuff, you come back, stick to the back, then the suit comes off and you go inside. It's a cool device, I mean. But the maximum weight for that is 80 tons. What is 80 tons? 80 times 1,000, 80,000 kilogram, or 80 times 2,200 pounds. That will tell you it's not a small thing, it's not a light thing. It's a heavy device. These airplanes, like you watch the 747 out of Chicopee here, when they take off fully loaded, that sucker is heavy. I forgot, 800,000 tons. I mean, when it's fully loaded, imagine there's tanks inside them. There's 5, 6 tanks inside them. Those tanks are heavy, they're not light. So when that plane is flying out there with that much weight, and if it hits somebody, we are in trouble there. We'll get to that, moving power. It depends on the mass and the speed, how fast they're moving, how heavy they are, So when the object is really heavy, we use something like this. We use kilo. Kilo is the letter K, which is 1,000. So instead of saying that many pounds, it's kilo pounds, or kilo kilogram, or kilo units. If it's mega, we use capital M. And this is, by the way, 10 to the third. A mega is a million, so I'll just go 10 to the 6. Giga. That's a capital G. That's 10 to the 9th. You have tera, which is a capital T. That's 10 to the 12. And we get peta, which is P, capital P, and that's 10 to the 15th. We hear that actually these units if you're buying a computer. As I said, I'm getting two brand new Mac machines come in. One is a desktop, top of the line. School pays for it. So this machine, it has 32 gigabytes of RAM. Giga. Giga means what? 1 billion. Most machines today have, if you're lucky, have 8. You know? 6 and 8. This has 32 gigabytes of RAM. It has 1 tera hard drive. 1 tera. What's 1 tera?
100 million?
Yep, a million. Yep. 1,000 billion, which is trillion. 1 terabyte of hard drive. It has 512K pixels. Retina eye, 32-inch monitor. 512,000 pixels. Most monitors come in, if you're lucky, 2,000 pixels. They go 2K. So this is 5K, which is 512, but they call it 5K. 512K pixels. So if you take the screen, you draw lines on it, 512,000 lines going across this way and 512 going across that way. The more pixels, the better resolution there. So you hear that terminology, the kilo, the tera, the gigabyte. When we start dealing with distance, for example, from the Earth to the Moon, I might have these somewhere actually here in our book. Some big numbers. Here we go. The speed of light, or you're starting seeing numbers 10 to the 9, see 10 to the minus 19, 10 to the minus 12. Well, instead of writing 10 to the 9th, they might use 8.99, and 10 to the 9th is G, 8.99 G, which means times 10 to the 9th. So you'll be asked to convert from, and by the way, these are the ones I was talking about, the mega, the giga, the tera, the peta or peta. Then there's the exa, there's the zeta, there's the iota. Iota is 10 to the 24. Anyone ever wonder why they call Google Google? Why the name Google? 10 to the power of 100, that's a Google. That's where the name came from. Yeah. If the number is really small, we use the smaller, the milli, 10 to the minus 3. The micro, 10 to the minus 6. The nano, 10 to the minus 9. The pico, 10 to the minus 12. The femto, the atto. So these are for the smaller values. There's the deci and the centi and the millimeters. Milli is 10 to the minus 3. Centi is 10 to the minus 2. That's 100th actually. And deci is 1/10. But these are for the smaller values. So I might even snapshot that later for you to have in your notes, to put that in your notes. Again, speed has to be meters per second. We didn't get to acceleration yet. We'll talk about that later. Some of the stuff doesn't make any sense to us right now because we didn't cover it now. You know. So how do you convert? If I ask you to convert, I said we have this device. We have a capacitor. You don't have to know what a capacitor is. And has a value equals to 22 microfarad. Micro. Can you tell me what is the value in millifarad? Again, you don't have to know what a farad is. All you know, a micro, 1 micro equals 10 to the negative 6, and 1 milli is equal 10 to the negative 3. Can you convert the value of that capacitor from micro to milli? So we have microfarad over 1. If I want to change it from microfarad to farad, 1 farad has how many? Or 1 micro is what? 10 to the negative 6 farad. If anything, not just farad. 1 micro is equal to 10 to the minus 6 of whatever that unit is. So if you go from micro just to farad, you're multiplying by 10 to the minus 6, which means in math, move the decimal point how many places? Isn't that move the decimal point 6 places to the left? So I can leave it like this, or I can write that 0.00000022. That's really what that number is. It's the same thing. By the way, if you end up with a problem like this and say, write the answer using 2 significant digits. If you write 2 significant digits, what's your answer is going to be? 0.00, right? But when you get a small number like this, is write the answer using 2 significant digits, they want you to switch it to scientific notation like this one. And that becomes 2.2 times 10 to the negative 6. When you write this, because again, the leading zeros don't only count as significant digits. Even if you put a bar over this, that becomes significant digits. But they usually want you to switch it to that format, so be aware of that. But that's not in milli. I want it in millifarad. So let me take that number and convert it now from farad to millifarad. 1 millifarad equals what? 10 to the minus 3? The farad will cancel each other out. So you will have what? 2.2 times 10 to the negative 6 over 10 to the minus 3. Now, if you remember from math, when you divide, what do you do with the exponents? Don't we subtract them? So 2.2 times 10 to the power, what's negative 6? Minus a negative 3. Minus a minus will make it what? Positive. So that's the answer in millifarad. To switch it from micro to milli, that'll be your answer. Or in some cases, you might have an example. Let's say we have a truck that's really heavy truck and it weighs 0.7253 gigapounds. Gigapounds. I say, you know what? I don't like that point gigapounds. Can you tell me what that is in terms of megapounds? From giga to mega. 0.7253 gigapounds. Let me convert that to pounds. One gigapound is how many pounds? We said 10 to what power? Is it 10 to the 9th? So the gigapounds are gone. But my answer in pounds now, I need to take it one more step now. Since pounds on the top, I want pounds on the bottom, megapounds on the top. And 1 megapound is how many pounds in it? A mega is 10 to what power? 6. So that becomes 0.7253 times 10 to the 9 over 10 to the 6 mega pounds. 10 to the 9 over 10 to the 6, that's 10 to the 3. When you multiply by 10 to the third, that's moving the decimal point how many places? 3 places. So the answer will be 725.3 megapounds. As I said, we're doing a lot of unit conversion because you're going to see problems given to you in different units and ask you to convert that. Let's take another example. Do a few more, then we'll call it quit for the day, which I don't want you to panic quickly. Give you a couple of days to think about it. We have a warehouse. You know, it looks like a garage there, and it's 20.0 yards. 20.0 yards. I made intentionally 0. 10.0 yards wide. And 15.0 feet high. Find the volume in standard unit, SI. Standard unit, that means in cubic meters, because that's a volume. SI standard unit. So really meter cube, that's what I need to know. What is the volume in cubic meters? And again, the conversion factor I'm going to be using is 1 meter equals how many feet? 3.281 feet. In case you forgot, and 1 yard has how many feet? 3 feet, right? So that's what I'm going to be using. The 10.10, this is yard, I just didn't write it. So this is the length, this is the width, and that's the height. I need to convert each one of them to meters. Let's look at the length. The length is 20 yard. Notice at 20.0, that means 3 decimal places. So when you get the answer for that, it has to be three significant digits, not decimal, 3 significant digits. This is yard over 1. I need to convert that to feet first, so I want yard on the bottom, feet on the top. 1 yard has how many feet? 3. If I stop now, my answer is going to be what? In yards. Next, I need to change it from, my answer will be in feet if I stop now. I cancel the yard. I got to convert the feet to meters. 1 meter has how many feet? 3.281. So the length will be 18.3 meters if you round that to 3 significant digits. Let's look at the width. 10 yards over 1. I convert from yard to feet. I want yard in the bottom, feet on the top. 1 yard is 3 feet. My answer right now in feet, multiply that. I want feet on the bottom, meters on the top. 1 meter has 3.281. Do the math, that should be half this number. 9.15 or 14 when you round it there. 9.14 meters, because this was rounded here. And finally, the height. The height is in feet. So in feet, I know how to go from feet to meters. 1 meter, 3.281 feet. So I'm converting each one to meters. You do the math, 4.57. Notice 3 significant digits for each one. Why? 3, 3, and 3 significant digits. Well, what is the volume? The volume of a box like this is length times width times height. That's the equation for the volume. Do we know the length? 18.3. Do we know what the width is? 9.14. The height? 4.57. Make sure you write your answer in 3 significant digits. 764. And what are the units for that? Cubic meters. Okay.